you're talking about colorfastness, especially with denim, it made me think of, that pair of jeans that leaves a memory on your white sofa that you were sitting there.
Yeah.
That, of course, we've come to know that as crocking.
Yeah.
Or for the sake of this conversation, croaking.
Yeah. Oh my, we're stretching that.
I know. Welcome to Clothing Culture, a fashion industry podcast at the intersection of technology and innovation. I'm Emily Lane.
And I'm Bret Schnitker. We speak with experts and disruptors who are moving the industry forward and discuss solutions to real industry challenges.
Clothing Culture is produced by Stars Design Group, a global design and production house with more than 30 years of experience. Welcome back to another episode of Clothing Culture. We are once again up at the tabletop where we are addressing questions that come in from the audience. You'll never guess what today's topic is about. Do you know what it's about, Bret?
No.
Dyeing.
That's pretty morbid.
Well, I promise it is not nearly as macabre as you might think. We're talking, of course, about garments to dye for, fabric dyeing.
Okay, that's a little more related to the industry.
That's right. Well, dyestuffs create the color that artists dream up, and washes impart that unique character, the personality, that hand feel that everybody seeks in an elevated garment. When you put those two things together, you can have magic. So we've had so many questions come in about how you make various decisions on the combination of what dye stuffs for what fabric and what finishes. So we thought, let's go to the table talk to address this very topic. So Bret, let's start at the beginning. How do you make some of those beginning decisions on what dye is going to be best for you, or how to dye?
Yeah, how to dye well. A lot of those decisions are sort of pre-made. Different contents of fiber usually dictate what type of dye stuffs that you use. There are three main kind of categories of dye stuffs: water soluble, water insoluble, and in situ.
And that's a new word for me, in situ. Tell me what that is.
It's a little more complicated. It's hard to distill it in a short kind of detail, but it's about polymerization. It's about two different chemical compounds that kind of coalesce together and adhere color to a surface.
Okay.
I guess that's
some
about
chemistry.
As simple as I can get.
Yes.
Yeah, most dyeing is all about chemistry, for sure, and close control of all different elements of chemistry: water temperature, pH level, etc., depending on what dye stuffs that you use.
I imagine that different fabrics have a different need with regards to the type of process that you use for dyeing.
Specifically, the type of dye stuff. So there are about 9 major dye stuffs, probably a few more, but 9 major. You've got reactive. That's generally for cotton, cellulose, and polyamide fabrics. You have pigment. That's an alternative dye process that is really kind of using earthen kind of materials and kind of washes out and using that washed out look. That's usually used for cotton or cotton poly and printing. Direct dyes, you can use cotton, rayon, silk, or wool. Dispersed dyes are mainly what's used for polyester fabrics. Acid dyes for nylon, then there's metal complex dyes, sulfur dyes, azoic dyes, and then there's unique dyes like vat dyes. And vat dyes are used mainly in the uniform business because the vat dye uses a adhesive almost that adheres the color to the substrate, and you get no color loss after washing, no reduction of color to sunlight. It's a pretty strong dye. However, the library for those colors are very, very limited. You use the vat dye company's black or navy or green or whatever, but they're very, very strong dye stuffs.
Wow. That's a lot to consider when you're trying to make decisions about the end result that you want for your garment. I imagine that there are kind of some core companies out there that this is their specialty. What would some of those key players be?
Well, without advertising too much in our industry, there's really good European companies. Huntsman is one that we use quite a bit. They have a very good quality dye stuffs, especially reactive, that we use them for. But there's others, Seba, Clariant, a number of them that are out there. And then each country has their own kind of dye companies that manage maybe less expensive dye stuffs. And they kind of range the gamut from, pretty good dye stuffs to maybe not so good. They might, if you might have some issues with some of them.
So
But they're a lot less expensive.
when you're talking pretty good to not so good, are you talking about color saturation? Are you talking
All the above: color saturation, longevity of color, crocking, which we'll get into a little bit, Colorfastness. All those things can be good and bad depending on the dye company that you use.
Okay, so let's talk about applications. I'm sure that just some dye better than others.
Yes.
This is going to be one of those episodes where we
Yes,
could have
it
a
is.
lot of ongoing fun about this.
Yes.
I've never
And
had
maybe
so
a
much
few
fun
people will
talking
laugh.
about dyeing.
Right.
Yeah. So let's talk about how hydrophobic, hydrophilic, how that affects dyeing and other considerations.
Yeah, well, you break, your basic fibers into hydrophilic and hydrophobic fibers. So hydrophilic means that the general fiber itself and or the fabric that's created from that fiber absorbs moisture. Cotton, great example. Pour water on cotton t-shirts, it sucks it in, that water stays till eventually it dries. And then hydrophobic it resists, it can't take in water. Polyester's that perfect example of that. Polyester really being plastic for all purposes, has no porosity, doesn't have any absorbent quality, and so therefore it's hydrophobic.
That's got to be really complicated when you're looking at a fabric blend that's like a cotton poly blend. You've got that combination of hydrophilic and hydrophobic. How do you proceed with those challenges?
In those cases, in a lot of cases like that, you could go through double dyeing. You could dye the cotton with reactive dye stuffs, and then you'd then go back and dye the polyester with dispersed dye stuffs.
Okay.
So you can get, depending on how that fiber is constructed, if it's cotton poly and it's twisted together, a cotton yarn and a poly yarn, you twist them, you dye the cotton, let's say in black, you dye the poly for red, and you have red and black kind of brindle.
Oh, so that's kind of how you get maybe some of those heathered looks.
Heathered would be that the fibers themselves, before they're spun, are mixed intermittently, is what they call it. And then those fibers are all spun out, so you get those particles running all the way through. And you can decide, in that case, you could dye only for cotton, reactive. The poly remains white, so there you'd have kind of if you dyed it with dark gray, you'd have dark gray and white, kind of melange looking. Mm-hmm. Or you could dye the two colors different and get multicolor melange.
There has been a lot of talk around the world about some of the harms that dye stuffs, the effect of, once those waters leave those or the water leaves the tanks, the long-term impact of that. In a recent trip that we had in India, pretty much everyone was very proud to talk about water reclamation services, the friendly dye stuffs, all of that are being embraced there. Can you talk a little bit about dyeing friendly?
Yeah, sure. And that's a major challenge within our industry, the dyeing, the usage of water, the usage of energy. They say that in terms of like basic cotton dyeing, I think you use 200 liters of water to dye just 1 kg of fabric. So, and then you've got to keep it hot. You've got to continually kind of allow that dye stuff to soak into the fiber. So it's water intensive, it's energy intensive, and then the effluents can be rather challenging for the environment. And certain countries have had less restriction on that, and therefore it flows into the rivers and causes all sorts of issues. And then most companies are kind of waking up and realizing the first step there is that water reclamation, where we saw that the dye stuffs go into a treatment plant. The treatment plant goes through and pulls all of that harmful stuff out. At the very end, you can just drink the water. It's so good.
Yeah.
So,
there was a factory that we were given water to drink that came through their systems.
Yeah. So thankfully, that's certainly on the rise. And then other people are exploring eco-friendly dye stuffs, and then eco-friendly alternatives to applying the color or a range of color to the actual substrate. And so some of those things you can use natural dyes. Natural dyes come in the form of insects, mineral, and vegetable material We kind of took a trip to El Salvador,
Right.
and they talked about indigo dyes and certain seeds that you could dye and impart this color naturally onto the substance.
It's almost
on the
like a
substrate.
return to history, really.
It
those
is.
techniques.
One of the biggest challenges with natural dyes today is that they're not very color fast in most cases.
What do you mean by color fast?
Well, indigo. So indigo, for example, is a natural dye stuff, and we know indigo as it relates to our
Denim.
denim and our jeans. We also know that you can get a jean to begin with that could look very, very dark, and after multiple washes, that jean becomes very, very light. So color fastness means color fastness to laundry, color fastness to light. In this case, color fastness to laundering or water. It slowly lightens that dye stuff. It doesn't have the ability to hold color over a long period of time. So those are some of the downsides to maybe some of the natural dye stuffs. But there's other things that you can do where you reduce the overall usage of energy and water. In like digital prints are on the rise. You're actually applying the print directly to the fiber, and you can do it with pigments, or you can do it with reactive, and you're actually reducing the amount of additional processing needed. And then there's dry dyeing technologies, all sorts of things on the horizon that will help in the path for eco-friendliness.
When you're talking about color fastness, especially with denim, it made me think of, that pair of jeans that leaves a memory on your white sofa that you were
Yes.
sitting there.
Yeah.
That, of course, we've come to know that as crocking.
Yeah.
Or for the sake of this conversation, croaking.
Yeah. Oh my, we're stretching that.
I know.
Yeah, there's two types of crocking. There's wet and dry crocking. So, and there are tests for each. When we're doing different tests, when the test comes out, they rate it on a scale of 1 to 5. 5 means little or no change, and 1 means radical change. And crocking itself, if you have a 1 or a 2, that means like if you put your jeans on or you put red pair of pants on that doesn't have very strong properties in terms of resisting that, that's that rubbing that happens where you're sitting on something and you sit on that white sofa and it leaves that color. So that would be dry crocking. Wet crocking, you take a red garment, you put it in with your white sheets, and all of a sudden you pull it out and everything's pink. So that's wet crocking in terms of that color leaching on to other fibers. And those are the two different terms.
And so are those things that brands just kind of decide, like, I'm okay with this tolerance level of, more crocking, or is it kind of an accident that's made? How does that come to be, and how can you prevent it?
I think most of the industry that's formalized has standards that they set in place. 3, 3.5, 4.0. The higher the scale, the less issues you have with the crocking, and most people have different levels of rigidity when it comes to that. There is limitations, however, if you're doing pigment, you're doing dark colors in pigment, like black pigment or dark gray pigments. You just have to accept that pigments themselves, much like indigo, they are going to have higher levels of crocking issues, and you can't get, for instance, a pigment dye or a pigment print to achieve a 4.0 or a 5.0. They're usually going to hover somewhere in the 2 to 3.5. And, buyer beware, there's tags, each one's uniquely done, washed separately. There's all these different, cautionary tags that go on garments.
Okay. So I guess it's time to finish this conversation. I'm just
Okay.
really full of these dad
Yeah.
jokes today, aren't I?
Yes.
So let's talk about finishes. I would say the next phase of imparting that character to a
Yeah.
garment. What are they? How are they applied? What's the range of opportunity within finishes?
Wide, really wide. Certain finishes can be done by machines, and you would have calendarization is one that used to use a long time ago. So you'd take a poplin or a chintz fabric and run it through calendarization, which are two steel kind of barrels, and it would polish the fabric, so it would look shinier. There's mercerization that kind of singes off fuzz and leaves both the yarn and the fiber very, very shiny. And there's also in the in mercerization, there is a chemical process that if you look at a side view of, let's say, a cotton fiber, you'll have two different ways that these fibers kind of go. And when light hits them, it kind of refracts light and looks duller. When you go through a mercerization process, those fibers lay flat within the spun fiber itself, and therefore reflects more light and creates more shine.
Wow.
There's brushing, sanding, all different types of things. They use little rubber balls that you put in kind of a washing unit that fluffs things. There's
that makes me think of our rack of tiny teas that we have that has 27 different finishes to show this is how it's going to feel.
Yes, they have different feelings. You can also have performance finishes. So adding into different fabrics like polyesters, you've got wicking, antimicrobial, UPF. There's anti-wrinkling, anti-static, anti-pill.
Cooling, warming, right? It's kind of like...
List is endless today.
So it really is, what do you want this garment to do? How do you want it to feel? And then from there, let's make some decisions.
For sure.
Oh, that sounds great. Well, thank you so much, Bret, for helping us dye a little better today and sharing your knowledge on this.
In our industry, we dye a little every day. Sometimes we dye a lot.
Well, on that note, I think knowing that our time is limited, it's time to wrap it up. So thank you so much for joining us on this conversation. Clothing Culture, do not forget to subscribe and stay apprised of upcoming episodes of Clothing Culture.